Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly challenge first question. So let us first read this question, then about the constraints, and finally the coding part for the same. So here you can see it is easy level question, so not that much tricky. Brute, brute force would also work here, but where is my cursor? Hmm. Here you can clearly see that it is up to 50, right? So brute force can easily work here. Means even n square, nlogn, any solution can work. So let us first read this question. You are given a zero index array of integers num. A prefix nums 0 to I is sequential if for all 1 less than equals to j less than equals to I, nums of j equals to nums of j minus 1 plus 1. In particular, the prefix consisting only of num 0 is sequential. Return the smallest integer x missing from the num such that x is greater than or equal to the sum of the longest sequential prefix. So the thing here is that we need to check for this condition, and then accordingly we need to go ahead and return the smallest integer x missing from the nums such that it is greater than or equal to the sum of the longest sequential prefix. So accordingly, for which they have mentioned this condition, means a particular prefix is sequential if it follows this condition, and whatever longest sequential prefix we will be finding, if that is there, means whatever sum which is there, if that sum number, basically the number, if greater than that number is present, then we will be returning that, else we will be returning that sum only. So this is the thing which we are required to do. So here if we check 1 2 1 2 3 and 2 5, right? So here the the sequential prefix is 1 2 3, right? And its sum is 6. And now if we check that longest sequential prefix of num is 6, right? And 6 is also not present in array, so that's why we will be returning 6 as the answer. So basically the thing is that if that longest sequential prefix which is there, means basically sum of that, if that is not present in the array, then we will be returning that. Else if it is present, then we will be returning whatever number which is nearest to that is missing, that we will be returning, means the smallest integer x missing from the nums, so that we will be returning. Now in this, if we can see 3 4 5 is a sequential prefix, then 12 13 14, that is also a sequential prefix, but they mention return the smallest integer x missing from the num such that x is greater than or equal to the sum of the longest sequential prefix. Now the first sequential prefix is 3 4 5, right? And if we add them up, 3 plus 4 would be 7, 7 plus 5 would be 12, right? Now comes the part that 12, which is the sum, it is already present here, right? Now the next number 13, that is also present. Next number 14, that is also present. So now next number comes is 15, right? So now here is that case only which they have mentioned is smallest integer x missing from the nums such that x is greater than or equal to sum of this. So basically 15 is that number which is that smallest number which is missing also in this, and it is also greater than this 12. So that's why we are returning here 15. So this was overall explanation for this question. Now comes the part that how we will be solving this question. So earlier I told you, because this is a easy level question, so brute force would also work. So we will be going ahead with that solution only. So now first let us take int n is equals to nums dot size, and then int pref sum equals to nums of 0. We are taking that as it is. We would have taken that int prefix sum equals to 0, but accordingly we would be required to modify for loop also. But the way I will be using the for loop, in that I would be required that my prefix sum already have nums of 0 as it is with it. So now for int I equals to, as we have already taken that nums of 0 in the prefix sum, so we will be starting from 1. I less than n, I plus plus. Now here what we are doing, we will be checking for the condition which is mentioned in the question, that if nums of I equals to nums of I minus 1 plus 1, then in that context what we are required to do is we will be just adding up our plus equals to nums of I, because that condition holds true, so this will be a sequential prefix and that we will be adding up. And if this case doesn't exist, right, so then we will be breaking out of this for loop. So till now we will be able to figure out with the longest sequential prefix, and basically it's sum also, because here we are doing sum. So that would be the case, right? Now comes the part which they are asking in this particular last line, that we are required to return the smallest integer x missing from the num such that it is greater than or equal to this. So for equal to condition, we will be checking that does that longest means, does this pref sum exist in this nums or not? If it exists, then we will be directly returning that. But if it doesn't exist, then in that context, we will be returning just that number which is greater than that. So now first thing is that we will be sorting our nums for easy access of all the numbers. Begin, comma, nums dot end. Now here we will be doing going ahead with that for loop for int I equals to 0, I less than n I plus plus. Then here what we are doing, that if nums of I, we figured out with that, right, equals to pref sum, right, then in that context we will be doing, because that already existed, right, so we will be just incrementing and that only we will be returning, and if it doesn't exist, right, so we will be just returning whatever our prefix sum was there. So this was with the case, it already existed there, right, so here you can see that in this 6 was not there, right, so it won't come into this condition, and here it will directly returning this 6, right, but in this scenario the 12 which was there, it was existing, right, so here nums of I equals to pref sum, right, so we will be at that point it was 12, right, so we will be incrementing the 12, it becomes 13, and then we checked that 13 already existed, right, so 13 again will come, 13 equals to pref sum, then it will become 14, then again it will check for 14, 14 already is there, so it will increment to 15, and then no more condition would be there where 15 is equals to any other number, right, so at the end 15 would be returned. So this was all for this particular question. Now comes the part for time complexity. You can clearly see that here it is order of n and here also it is order of n. But here it is log n, right? So that's why the time complexity becomes n log n. And about the space complexity, we are just taking this pref sum as the extra space. So that's why the space complexity becomes order of n. So this was all for this particular question. If you have any doubt, you could comment that down. And if you like this solution and even the explanation, you can like this video, share this among your friends, and do subscribe to my channel. So this was all. Thank you.